Today we will discuss a new problem related with the three-moment equation. So please note out the question. Analyze the continuous beam ABCD as shown in the figure. If support C sinks by 5 mm and also given some details related with Young's modulus and moment of inertia. Young's modulus value is given as 15 kN per millimeter square and moment of inertia value is given as 5 multiplied by 10 raised to 9 millimeter raised to 4. Okay. So now we will move on to the question. So the given question A, B, C and D. So here 4 supports are given. Okay. The given question 4 supports are given. So our first intention is to divide them into two parts. Means first one will be A, B and then C, A, B. Then after that you have to consider B, then C and D. And you have to apply the three-moment equation for these two beams. Okay. So first of all we will consider this ABC portion. Then only we will move on to this BCD portion. Okay. So next our step is to find out what is our next step? Free moment diagram. For finding out the free moment diagram, in this case, if you consider the AB portion, a point load is acting at a distance of 2 meters from the point support A. Okay, that is 30 kN, and we know that the bending moment value is going to be WAB by L. Okay. So if you substitute the value 30 multiplied by 4 multiplied by 2, you will get the value as 40 kN meter. Okay. So please try to do by yourself these values. Then after that our next intention is to find out the area. Okay. This area can be calculated by the half multiplied by this ordinate distance, that is you will get in this case 40, then multiplied by the span length, that is 6 given in the AB span distance. Okay, so this is regarding the area. First A1 area you can easily calculate. Then about the center of gravity distance, that you have to take from the left support, that is support from the support A. So if you are going to consider L plus A by 3, this is the general equation. Already we discussed in the previous case. Okay. So L plus A by 3. L means in this case 6 and then A means 2 and you will get 8 by 3. Okay. So this is regarding the AB portion. Then we will move on to the BC portion. The point load is acting at the center point. So the value is again going to be what? WL by 4. You can easily calculate WL by 4 and it is going to be 90 kN meter. Okay. Then regarding the area, if you can directly take the right angled area, that is half multiplied by 6 multiplied by 90 and you will get the value as 270. Okay. Then regarding the A2, center of gravity distance from this support. In this case it will be the center span, that is 3 meter. A2 is going to be 3. Okay, A2 is going to be 3. This is all regarding the AB portion and BC portion values. Okay, then also you can also calculate the CD value also. The free moment diagram for CD also is going to be the 40 kN is acting at the center point. So the CD value is also going to be what? WL by 4. Okay, and this area you can easily calculate using the right angled theorem, that is half multiplied by 3 multiplied by 30, that is equal to 45. So this is the way we will find out the area and the center of gravity distance. Okay, our first intention is to work out for this ABC portion only. And in the given question there is another statement given that this support C is 5 mm below the mid support B. Okay, so in the given question A, B and C, when you are applying load, this C is going to be settled down by 5 mm. Okay. So then you have to consider, in this case, A and B is here and C is going to be down. So when you comparison with this B support, if the point C is down, then you have to take the HC value is going to be minus 5 mm. Okay, once again I will repeat. When you are comparing this point B with respect to C, if the point C is below the point B, okay, this mid support, then the value is going to be minus 5 mm. Okay, in the given question it is mentioned that point C is down. Okay, and for finding out you have to convert it into meter, since here all we mentioned regarding kilonewton and meter. And regarding the Young's modulus also, millimeter square you have to convert it into meter square, and also here moment of inertia also you have to convert it into meter raised to 4. Okay, so this is all regarding the values, and if you just substitute the equation I think you know that MA multiplied by L1 by I1. In the given question for the AB portion, moment of inertia is going to be 2I, and for BC portion it is also going to be 2I. And you have to substitute the values 2I correspondingly, and 2 MB multiplied by 6 by 2I plus 6 by 2I, since both the case parallel is same, and here also if you substitute, and in this case HA value is going to be 0. Okay, there is no settlement at the support A. In the given question there is no settlement is given for the support A. And if you directly substitute the values, and we know that MA is going to be 0, since if you are considering the bending moment at the support A is going to be 0. But in the case of MC, it is not going to be 0. Why? Why it is not going to be 0? Since there is a continuation of D is also, CD portion is also there. So it is not possible to be 0. So finally if you substitute the values, 12 MB plus, after substituting 3 MC. And for easiness we are multiplying by I, throughout by I. This moment of inertia will be cancelled, and you can directly substitute the equation 5 multiplied by 10 raised to minus 3. Okay. And also you have to notice that this negative sign is also very important. Okay. Negative sign indicates the support C is below the support B. Okay. And you will finally get the value as this 12 MB plus 3 MC equals minus 940, and represent this equation as number 1. We will move on to the second part, that is the beams BC then CD. Okay, BC, CD. And we already calculated the values of bending moment, free moment diagrams, and for the BC portion and CD portion. And also we know that the center of gravity distance also we calculated here. It will be 3. Center of gravity distance will be 3, and here it will be 1.5. Okay. Then in this case, you have to consider the values of this unequal settlement, how it is going to come. In this case, we know that the C value is going to be down. The support C is going to be down. This is B and this is D. So with the comparison with this C, when you compare with this C, this B portion is up and this D portion is also up. So the values of HB equal to, in this case it is 5 mm. It is 5 mm, and HD is also going to be 5 mm. Okay, in both the cases it is going to be, when comparing with this C, the center point or middle support, it is in the position of up. So it is going to be a positive value. Okay, that is an important thing you have to mention here. And you have to convert them into the unit also, you have to consider meter. And then just substitute the values. Also check the moment of inertia. Here it is only given, I value is only given. So you have to substitute accordingly. And if you substitute the values, you will finally get the values as, in this case, the MD is going to be 0. Why? It is the end, simply supported end, and the final value is going to be 0. And here for easiness, we are multiplying with throughout I. So if you are multiplying with throughout I, here one times will come I, and here also one term is going to become I. Okay, so you have to provide that I value as, okay, I value is going to be 5 multiplied by 10 raised to minus 3. Okay, that you have to substitute, and finally if you substitute the values, you will get the equation in this format, that is 3mb plus 12mc equal to 585. So please do the calculation by yourself, and after that, for easiness, again if you multiply this equation with 4, you will get an equation in this format. For easiness, if you compare with this equation number 1 for this AB and BC portion, here both the terms will be 12 MB. So if you subtract, you will easily get the value of this MC as 72.889 kilonewton meter. And also you can easily calculate the value if you substitute this MC value in this equation. You can easily find out, and it is going to be minus 96.556 kilonewton meter. So finally you can write down as MA value is going to be 0, MT equal to 0, and this MB and MC also you can note down. So this is the case related with an unequal settlement with different loads are acting and the supports are also more than 3. So this is the steps for this type of question. So with this we will wind up today's section.